Um, Oscillations, that is chapter 19 of the old book. This is the new book, so it is chapter 18. Um, Damped oscillations. So now we theoretically we described earlier oscillations that would continue forever. However, practically we can all the oscillations that we see around us, they actually come to a stop or they die out, because there is a gradual decrease of the energy that is contained in that energy reduction is due to friction. Now if you take a child swinging a child on a swing, um, the child will actually come to a stop unless someone pushes or she puts energy for the swing to swing continuously. So unless that extra energy is added, it will come to a rest after some time. So this friction, or this the force that acts against an oscillation and making it come to rest is known as damping of an oscillation. The reduction of the amplitude does not actually happen linearly. This reduction happens in a manner known as um, exponential decay. Exponential means exponential means the decay happens in relation to the earlier decay. Now the reason why this happens is, now when the swing moves back and forth really fast, there is more air resistance to overcome. So as a result, because of the high air resistance, the amplitude will actually reduce faster. But then with time, it does not swing that much. It is going to swing slowly. As a result, it is going to lose energy much more slowly, because there is only a little air resistance to overcome. So that is the reason why you have that curved shape here on the graph, 18.25 figure. So that shows us that there is an exponential drop in the energy, and then finally it comes to a stop. The interesting thing about this is, actually, even though the amplitude decreases, the frequency of the oscillation does not change. That is, if the child completes a single swing in 2 seconds, at the beginning itself, and um, at the beginning and at the end also, comes to um, it actually comes to the same it takes only 2 seconds to complete the same oscillation, right? To complete a single oscillation, it takes only that much time. So you can see that exponential envelope here. So that means there is a curve, right, like that. That is, the reason is because there is an exponential reduction in the um, energy, right? I hope you understood that part. This effect is known as damping effect of oscillation, or it results in a damped oscillation. Right, write down a note: damped oscillation. Theoretically, oscillations can continue forever. However, in reality, forces such as friction, air resistance will reduce the energy that is needed for simple harmonic motion to continue. This effect is known as damping of the oscillation. The damped oscillation can be graphically represented as follows. The damped oscillation can be graphically represented as follows. Please draw figure 18.25. After you have completed writing, after you have completed drawing the figure, write this note. The characteristic reduction of amplitude is known as an exponential decay. This happens because when the oscillation occurs at a higher pace, when oscillation happens at a higher pace, there is more air resistance to overcome. There is more air resistance to overcome. That results in rapid reduction of the amplitude. With time, the rate at which amplitude reduces will decrease because there is less air resistance to overcome, because the oscillation is taking place at a lower rate. Leave a line, put a star and write down. Despite the damping of the oscillation, the frequency does not change. Which is a characteristic of simple harmonic motion. Right? I hope you understand that. That means if a single swing is completed in once every 2 seconds, then at the beginning, that is here or here, for a single oscillation to take place, it takes only 2 seconds. I hope you understood. Right. We will discuss the practical activity in the next video.